Hello everyone, welcome again to our summer practice program. In this video, I will go over problems in quiz 1 of AMC8 plus. Now let's look at the first question. So this is about a quantity called BMI. According to the formula, it's the weight divided by the square of the height. All right, so Thomas, according to assumptions, Thomas, his current BMI is 27.3, so which is his current weight divided by the square of his height. That's 1.5 meters. That is given. Okay, so his goal. So his goal is to become ideal. Okay, so that means at the most the number should be 24.9. So that is the new weight divided by 1.5 squared. All right, so from here. One way is you calculate W and the new weight by these two formulas, by the two equations, and then you take the difference, right? So what you need to figure out is the difference. Well, but in fact, you don't have to do that. A quicker way is we just use a little algebra. So from here I get the W equals to 27.3 times 1.5 squared. And this new weight is 24.9 times 1.5 squared. All right, so you see they share a common factor, which is 1.5 squared. Okay, so then when you take the difference, you can take this one out, square, and what is left is 27.3 minus 24.9. This one equals to 2.4, so it's 1.5 squared times 2.4. Well, you can calculate, this is for 5.4, so 5.4, the unit is a kilogram. Okay, so this is a kilogram. What you transfer is you transfer this to pounds. All right. Okay. So here we have the formula. It says 1 pound equals to 5.11 kilograms. So which means you have more pounds. 1 kilogram has more than 1 pound. Okay. Right. In terms of the formula, so this one equals to, so by the formula, I get this should be 5.4 multiplied by 1105. Which is, you can calculate, which is 11.88 pounds. Okay, all right. So the problem asks to find the nearest integer. So okay, so 11.4 obviously. 11.88 obviously should be 12. Okay, so 12 is the answer. All right. Now let's look at problem 2. So problem 2 is a question about a fraction. Okay, so what you need to do is you need to basically find the reciprocal of the fraction. Remember, when you do the reciprocal of the fraction, you need to switch the numerator and the denominator. Okay. So we have two ways to solve this problem. One way is forward. That one we don't need to use algebra. And the other one is backward, and we need some algebra. All right, so first let's look at the forward method. So method 1, forward. All right, so you see the goal is we start from the 11 over 21. So this is the original fraction. We need to write it in terms of 1 over something, and then there are several layers, right? Okay, so the first layer, we write this is 1 over 21 over 11, right, clearly. And this one, 21 over 11, you see it can write as 1 over 10 over 11. So this moves to 1 over 1 plus 10 over 11, right? Okay, so it's not done yet because we need another floor. So that's also 1 over something, okay? So we just do it again. So this guy equals to 1 over 11 over 10, right? So, okay, so this one equals to 1 over 1 plus 1 over 11 over 10. Now, 11 over 10, so we use the same procedure. So this guy is 1 plus 1 over 10. All right, so if we summarize, we put everything back, we'll get this one equals to 1 over 1 plus 1 over 1 plus, and this is 1 over 10. So if you compare what we want right here, so 1 over A should be the same as 1 over 10, so A equals to 10, right? Okay, so we got A is 10. So this is the forward approach. So here we don't use any algebra. Basically, is we start from fraction and we find this reciprocal and we split into two parts. One is the integer part and the other one is the fraction part. And that's it, right? All right. Now, let's look at the second approach. The second approach will go backward, use some algebra. All right. For the second approach, we go from the right-hand side. So let's look at the right-hand side. So that's 1 over 1 plus 1 over 1 plus 1 over a, right? Okay, so first let's figure out 1 plus 1 over a. Okay, so let's put it here. So 1 plus 1 over a. So this is the additional two fractions, except here we have a letter a. So the method is the same, right? So we first just use the same. So this is 1, so 1 is 1 over a. We just change it to the same denominator, right? So this a plus 1 of a, so this is a plus 1 over a. Okay, so I put it here. So this equals to 1 plus 1 plus, this is 1 over a plus 1 over a, right? Right here. Okay, so from here. All right, so then if it's 1 over, it's a reciprocal, we just flip the numerator and denominator. Okay, so this equals to 1 over 1 plus, I just flip it, so it's 1 over a plus 1. Now, let's do it again. Okay, so let's put it here. So I want to figure out 1 plus 1 over a plus 1. So again, we just use the same denominator. So this is 1 plus 1 over 1 plus 1. So this is 1. And then you plus a over a plus 1, right? So this is equals to a plus 1 and a plus 1 plus a. This one, you just combine the like terms, okay? So just combine the like terms. This guy will give you is 2a plus 1. All right. So then we have this equals to 1 over 2a plus 1 over 1 plus 1, right? A plus 1. Okay, so now it's a reciprocal. You just flip the numerator and numerator and the denominator. Okay, so that's what we have. This we get. This is a plus 1 over 2a plus 1. Okay, so then we see eventually we get this guy equals to all the way right here, right? By use this algebra. So when we say algebra, what is algebra? Well, a simple way to say is you just work with the letters, right? Okay, work with the letters and we combine like terms. That's it. All right. Okay, so then what do we have here? So I get this. So what do I want to go is one of this equals to 11 over 21. And then here we need one of the most applications of algebra is to solve equations, right? You set up equation, solve equation. Okay. So I can solve the equation here. So from here, okay, I get fa plus 1 over 2a plus 1 equals to 11 over 21. So from here I get, you see, if two fractions are the same, so what you should have is the cross product is the same, right? So I have 21 times a plus 1 equals 11 times 2a plus 1. Okay, so from here you can solve this 21a plus 21 equals 22a plus 11. Okay, so then you have 21a, 22a, 21, and 11. If you move to the this one to the right-hand side, and then you get this a equals to 10, right? So because 21 minus 20 is 22 minus 20 is a, and the other one is 10. Okay, so you just get the same answer, a equals to 10. So this is an algebraic approach, which is more robust. I would say you don't have to play any trick, you just follow the procedure. Right? Okay. All right, so this is the second problem. Now let's look at a problem 3. So problem 3 is a geometry problem. It's a problem about solid geometry. Okay, so what we have here, we have a rectangle. So we start from a rectangle box, and then you unfold it, right? Okay, so this gives you a two-dimensional picture, and this is so-called a net. So from here, basically, we want to recover the rectangular box. Okay? Let's see it. So this we need just a little bit spatial imagination. So you see, if we put it back, so obviously from this picture, what we have here. So I have this guy is 10, right? Obviously, and because I folded this. So the two sides, they have to match. They're basically the height, right? So basically it's the height. So this is basically the height, right? So if I put it here, so if I try to put this one, right? So this will be, so this will be 12, this will be 12. And okay, so here will be 10, and here will be the 10, right? So here you need to figure out it's basically the height. Okay, now also one observation is, what is this guy, right? So this one is you fold on the top, which is exactly 12, has to be the same as this 12, right, in order to fold the top. Okay, so this is when you figure out, this guy is 12, right? So this is 12, maybe I put, so this is 12. Right, so if this is 12 and this is 40, then you immediately get this guy has to be 8. This is 8, right? Okay, so then, oh, let me use different color. So this is 8, this is 8. Okay, so I get this is 8, this is 8, and this is 8, right? So this will go back to a rectangle box from a two-dimensional flat picture. Now you see, okay, so we have completely recovered this rectangle box and the way to calculate the volume. So now we say, all right, so the calculation of volume, it's straightforward. It's the 12 multiplied by 10 and then multiplied by the height. So that's 960. Okay, so now let's look at problem number 4. So problem number 4, so what we have is again a fraction problem. So on the left-hand side, we have addition of m fractions, and on the right-hand side we have something is 1985 over 2020. Okay, so we're going to solve this is inequality. Okay, so the problem for things like this, if you don't know the trick, this is quite hard. So what is the trick? The trick is right here. So this is a very classical equality, the famous trick to deal with this kind of addition of fractions, right? So this is what we have. So let me rewrite here. So we have n times n plus 1 over, this is 1 over n minus 1 over n plus 1, right? So this is the equality that is always correct. Now you can check this by the same approach, right? So if you have two fractions, how you find the difference? So what you do is you find the common denominator, right? So I can write this, it's just n times n plus 1. And the first guy is, this is n plus 1, right? Okay. And the other one is you minus n, so you get this n cancel with n, you get this 1 over n plus 1, right? Okay, so let's say now we agree this one is correct, and then we just apply to this addition. So 1.2 over 2 plus 3, and all the way to 1 over n times the n plus 1, okay? Another advantage of algebra is you don't have to write all the cases. You can just use this one letter to represent all scenarios, okay? All right, so then if we apply the formula, we say this is just 1 over 1 plus minus 1/2. This is 1/2 minus 1/3, and blah, blah, all the way to 1 over n minus 1 over n plus 1, right? Now, what's good about it? Okay, the good thing is now you have all the cancellations, right? All the way to this. There are two things that survive. It's the first one and the last one. So this is just 1 minus 1 over n plus 1. Okay, so this is a very famous trick, very useful, and you see this again when you go to college, when you learn calculus. Okay, you will see it again. All right, anyway, so now what we want this guy to be bigger than 80, 90, 85, about 20, 20, right? Okay, so what does this mean? 1 minus something is bigger to a fraction on the right-hand side. So we just want this guy to be, has to be less, right? So this one has to be less than 1 over 85 over 2020. Okay, so you calculate this guy. So this is 35 over 2020, right? Okay, so you want to 1 over n plus 1 less than 35 over 2020. Okay, so now you can do the calculation, right? Do the calculation. You want this guy has to be bigger than 2020 over 35. And from here, you can very easy to calculate. You need n to be bigger or equivalent to 57. So 57 is the smallest possible n in order for this one to be true, right? Just calculate this one out, some fractions you see. All right. Okay, so then the answer is 57. So for this problem, the key point is this identity. All right. Now let's look at problem number 5. The problem number 5 says asks how many 5-digit positive integers. Okay, so this is 5-digit integer, right? Okay, so they are the middle 3 are 1, 2, 3, and we have the first one is A, the last one is B. What we want is we're looking for those which are divisible by 3. So here what we need is the divisibility test for 3. So let's recall. So we need the divisibility test for 3. Okay. All right. So the divisibility test for 3. So if you don't know this, you can check the chapter 3. Oh no, chapter 4. Okay. So you can look at the chapter 4, right? Chapter 4 of the book. Oh, also, by the way, the previous trick is also in the textbook. You can look at this chapter 5, the fraction. All right. Okay, so this is the divisibility test for 3. What is divisibility test for 3? So a number, so that it says the number is divisible by 3 if and only if the addition of the digits is divisible by 3. So let me write this. The general way to say is, for example, I just use 4 number as example. Say I have a 4-digit number. So this one divided by 3, the remainder is the same. A, B, C, D is the same as the sum of digits. So here I put more 3. Okay, so just means they have the same remainder. They have the same remainder when divided by 3. By 3. Okay. All right. Well, okay, so then, especially like if one is divisible by 3 and if and only if the other one is divisible by 3. So here, so what we have is, which basically we just want, look for A plus 2 plus 1 plus 3 plus B. This one is divisible by 3. So divisible by 3, so here I use the notation means the remainder is 0 when divided by 3. Right, so this one just means A plus B plus 6 is divisible by 3. Well, 6 is already divisible by 3. So you just want this A plus B. This guy is divisible by 3, right? Divisible by 3. All right. Now, from here, there are 2 ways to continue. One way is you just do casework. So, okay, A plus 1 divisible by 3, which means A plus 1 could be 3, and A plus 1 could be 6, A plus 1 could be 9, and A plus 1 could be 12, and something like, right? So you just keep A plus 1 could be 15, A plus 5 19, oh, sorry, 18. All right, so you do caseworks. Now, but a quick way, so here, a quick way to do, so here we can do is, approach 1 is you do caseworks. 2 is a shortcut. The shortcut, again, we use the divisibility test. So by the divisibility test, the addition of the 2 numbers divisible by 3, if and only if you put these 2 numbers together, is divisible by 3. So this is the same as saying 2-digit number AB, this guy is divisible by 3. All right, well, so which means the problem is reduced to find, but because here the A cannot be a 0, so if you put AB together, it's indeed a regular 2-digit number, right? Okay, so basically we just need to find the number of 2-digit numbers AB that is divisible by 3. Okay, so that is very easy, right? You say, okay, the first one is obviously, the first one is 12, right? So we have it's 12. And then let's say 15, and all the way to what is the last one, 2 digits. The last one is 99, right? So this is 3 times 4, and this is 3 times 33. Then in total, of course, you have is 33 minus 4 plus 1, which is 30, right? So in total, we have 30 different pairs of A and B. All right, now let's look at a problem 6. Okay, so problem 6 says we have a partial integer that is the product of 2 different prime numbers, and if you add all its divisors together without itself equals to 100. So the question is, what is the sum of the digits of m? Well, basically, we need to find what m is, right? And then we just add the digits together. All right, so what we have is n equals to p times q, right? So here the p and the q are 2 distinct different prime numbers, right? Okay, so now we can find out, we can write out all of its factors. So factors of n, which the first one is 1, and then p, and then q, because p and q are prime numbers. So that's all the prop divisors we have. And the last one, of course, is the m itself. All right, so according to this problem, if you add these three together, so what we have is 1 plus p plus q equals to 100. And then here we have ap plus q equals to 99. So the problem is basically reduced to the scenario. If you have two different prime numbers, now if you add them together, if the sum is 99, what are these two prime numbers? Okay, so this belongs to type of problems that has been tested several times in AMC8 and AMC10. So what is the key here? The key is, if you look at the right-hand side, 99, so this guy is odd number, right? It's odd number. So if you have sum of two numbers is odd, then one of them has to be even, right? So we get, okay, so one is even. Okay, so maybe let me put it this way. So it has to be even plus odd, right? It has to be even plus odd. Okay, so we know both. So first of all, we know both of them are prime numbers, and this is number one. And number two, we know one of them is even. Okay, and then we know there's only one even prime number, that is 2, which says one of them has to be 2, right? Okay. So then from here, we get one of them is 2, right? Okay, so it doesn't matter, let's say P is 2, so we say P is 2. It doesn't matter, it's symmetric, so P is 2. And then we have Q is 97, and this is indeed valid because 97 is it's a prime number. So from here, I can derive what is my n. So my n will be 2 times 97, so that is 194. Okay, so what we need to find is the sum of digits. So that's 1 plus 9 plus 4, which is 14, right? Which is 14. All right. So here the key is we first of all write out all the divisors, and then we use the thing here. Maybe let me emphasize here. So here we have the only even prime number is 2. So 2 is the only even prime number. All right, now let's look at problem number 7. So number 7 says Ben, he has 2 coins, each has radius 1, and he wants to put these 2 coins, so he has 2 coins, so he has 2 coins, each has radius 1. Now he wants to find a square to contain both coins without overlap. So the question is, what is the smallest square that he could use? When you think of the arrangement, right? So you can do like things like this, but this is not the optimal one. Okay, so what you should do is, clearly, you should put on the diagonal. The diagonal is the longest, right? All right, so what you could do, you should put it around the diagonal. Okay, so that's what we have. So my picture is not very accurate. Well, but anyway, so this is what you have. So you have these are 2 centers, okay? Now, so here's a principle. If you have a geometry problem that involves a tangency means, so this is tangent, right? So you have a circle, tangent to a line, or circle, tangent to circle. Then what you should do, as always, you should connect the center of the circle with those tangent points. You connect, so first we connect the centers of those tangent circles, and then you connect the center to the tangent point, right? So here is, let me write down. So here is the general principle. So when you have the tangency type problems, you should connect centers of circles. Well, just draw some helping lines and centers to the tangent points. All right. So for example, for here, what you should do is, first of all, I connect the centers of the 2 circles, and then I connect to the tangent point, right? So here we have these 4 tangent points, so I connect them. All right. Okay. So now let me mark all those given numbers. So this guy's 1, 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 this guy's 1. Now the reason we connect those points is because we can easily figure out what they are, all right? Okay, so now what we want to figure out, let's see. What we figure out is the side length of this, right? So you see, okay, so if I do the projection, I see I already have this. This is a right triangle, so this is 1. Okay, now because of symmetry, so this is isosceles triangle. So this one, so basically what you figure out is this guy, right? So this is the only quantity that you need to identify. Here you have isosceles triangle. So let me single it out. Okay, so let me single it out. So here I have isosceles right triangle. So this is 45. This is 45. So they are the same. And here the hypotenuse is 2. So what is the legs? Now we know for hypotenuse for an isosceles right triangle, right? If they are the same, so the ratio we know if this is A, then this is just the square root of 2 of A, right? A squared plus B squared, A squared plus A squared. You take the square root, right? So this is isosceles. So from here we say, okay, so this is A, this is A. I just get 2A squared equals to 4. I get A squared equals to A squared equals to 2, right? Okay, so you just use the Pythagorean theorem, right? Use Pythagorean theorem. Pythagorean. Okay, so I get A equals to the square root 2. Okay, great. So I get a question mark. This guy equals to the square root 2, the square root 2. So if you combine things together, what you have, you get is 2. So this is 1 plus, so it's 1 plus 1 plus the square root 2. So that's 2 plus the square root 2.